Now, let's take a look at how IVIM is implemented in Dipy. In order to use IVIM from Dipy, all you need to do is import the IVIM model from the IVIM function in the Dipy package. It is within the reconst module. First, let's load the raw data file, the B value, and the B vector file. Once that is done, you can use load nifty, or you can alternatively also use load nifty data, or alternatively you can just use load nifty, which would return an affine along with the data. Then you read the bvals bvex, and you can create a gradient table. An important parameter here is the b0 threshold. The b0 threshold for IVIM is important because you want to know which one is the B0 and which one is a non-B0 diffusion volume, because for IVIM we go for very low B values. So this should always be set to 0. Then we just print out the data shape. It is of this size. As you can see, this is 21 gradient directions, including the B0. This is just an example slice to show how the data looks. Okay, and for the sake of this example, all we're going to do is take out the centered portion to fit the IVIM model. Okay, using the IVIM model is very simple. All you need to do is pass the G tab, that is the gradient table, and give the fit method. We have two different fit methods. One is the TRR and the other one is the varpro. The bounds are optional, but I have just printed them out over here. So the bounds are set in this fashion, where this is for the S0. So in this TRR stands for the nonlinear least squares fitting, also known as the segmented fitting. It has multiple names. How this basically functions is that you initialize the model with two linear fits, one for the perfusion fraction and the other for the diffusion fraction. And then you use a nonlinear least squares to finally optimize for everything. And the first parameter has bounds 0 to infinity, the second parameter from 0 to 1, and so on. So this is how the bounds are passed to the model, and this is how you fit the data. Okay, it will sometimes generate the warning. The warning is basically saying that it is not like the nonlinear least squares, that is the last step of the TRR method, could not fit the data. So it is just giving you the results that were used as initialization. This x0 is the initialization for the nonlinear least squares optimizer. Okay, then we take the estimated parameters. Here we pick it out for one example voxel. As you can see, the IVIM fit object can return this via model params, and this is going to be a 3D object, like it will have multiple things inside it that we will see in the next cells. Here is a helper function that is written to basically plot the data. This entire example is available on the Dipy website, so under tutorials, so you can always go ahead and look at it. Then this is the S0 predicted. It is very similar to the actual S0 volume. Then this is the perfusion map, the perfusion fraction. This is the perfusion map, the D star, and this is the D. As you can see, the segmented fit is kind of noisy as expected. And you can see, like, since it's a convex combination, you can see things that are opposite, like in the sense that here it is overfitting. You can see that this was classified, like there's a lot of misclassification rate, essentially. Then next, we fit the data with the varpro method. This is the one which I explained in the previous presentation. Same way, it is very easy to use it. You can also play around with the bounds. Just remember that this takes 3 bounds as input. Here we don't optimize for S0. So, for example, here in the TRR method, we had one that goes from 0 to infinity, but for varpro we don't need that. All of them have been set to 0 to 1, and that's how we're using them. You can play around with the bounds however you want. Then these are the estimated parameters from the variable projection model, variable projection fitting. And let's take a look at how well the fitting did. So the blue line shows the TRR method, that is using the segmented non-linearly squares fitting. And this is the variable projection. This is for an example voxel. As you can see, the goodness of fit even visually looks better. There is no overestimation of the diffusion part, whereas in the perfusion, the fit is much better, which results in better estimates. You can see that in the maps for the perfusion fraction, the perfusion coefficient, and the diffusion map. As you can see, the predictors as 0 and measured as 0 look very similar to one another. And yeah, that is about it. You can also use the IVIM via the workflow module. So all you need to do is open the Anaconda terminal. In here, you say dipy fit IVIM. I'm going to just print out all the options. You pass in your data in there, and that should basically give you the options of what to pass and when to pass. It takes 3 files that are compulsory inputs. One is the input file, then the bval file, b vector file, and the mask file. If you don't have the mask file, you can always use it by generating the mask using median also, which I'm sure you've seen in other tutorials. All right, this was the implementation of IVIM. If you have any questions, do reach out to me. And this example, as I mentioned before, is available on the Dipy website. Enjoy the rest of the day. Thank you.